Go on. Go on. Okay, part three. The last part for the extraction of 2017. So on the last one, on the last question, we just proved that sine x equals -1 plus root of 5 all over 2. So the next question is saying hands, and then we continue from there. Calculate the coordinates of the points of intersection, right? Points of intersection. So we know the points of intersection satisfy this equation. So here's the interval right here. So I'm going to use the rules of general solutions. So the first step would be to look at this value, right? So it's -1 plus the root of 5 all over 2. This is equal to a positive 0.62, right? That's a positive. So I know where to look now. So I'm gonna calculate the reference angle. Reference angle is equal to inverse function. So this gives me 38.17 degrees. That is my reference angle. I know that this is positive. So with the quadrants, right? Remember the past diagram. I know you guys saying complaining students and teachers what you have that acronym. So here, sine is positive this side as well as this side, right? So it's 180 minus theta here. This is just theta. This is 180 degrees plus theta, and then on the fourth quadrant, it's 360 minus theta. This is the fourth quadrant. So then you have 1, 2, 3, then you have the second one, then you have the first one. So looking at the first quadrant, x is going to be equal to 38.17 degrees plus k multiplied by 360 degrees, right? So k is element of integers. Okay, and then you have the second quadrant, right? So x is going to be equal to 180 degrees minus the reference angle, which is 38.17 degrees plus k times 360 degrees, k element of integers. Right, so for me to find the solution, I will need to substitute the value of k for me to get the full coordinates. I need coordinates, so I have to substitute the value of k. So going to my calculator, I'm gonna say sine, no, not sine. I have 38.17 plus 360. So let me substitute on 360. Let us look at the interval. Right? It's very important for me to remember the interval. The interval is between -270 degrees and 90 degrees. So I'm looking for values within this interval. So if I substitute the 0, let me substitute firstly -1, number below 0. So I'm gonna get 320. It's not within the interval, so I'm going to ignore the value. Let me say 0. 0. Okay. 0 gives me this value. So I already have a coordinate. So it's going to be equal to 38.17. This is within the interval. Right? And then to get the corresponding y value, remember the equation of f or g. The equation of g was 2 sine p of x equal to 2 sine x minus 1. Then the 1 of f of x was equal to cos 2x. So I can substitute within these values. So I'm going to say 2 cos 2 into 38. 38.17. This is equal to 0, 24. Those are my first coordinates. So going to the second one. Let us look at this one here. So we can solve that. That's 18 degrees minus 38.17. This is equal to 131.83. I know it's part of a solution because it's within the interval. Zero. No, it's actually it's not in the interval. So end at 90. So it's not within the interval. So let us say I substitute one because of I have 141, 83 degrees minus 360. Let us say I put negative 1. It's not within the interval. Let us say, okay, sorry, this is a plus. It's my error. Plus. Yes. So this is equal to 218, negative 218. It's within the interval. So I have negative 218 degrees. Okay, 218.17 degrees. Now, for me to find the corresponding y value, I'm going to say cos 2 into negative 218 degrees. So my answer is 0.24. Okay, let us see if I can get another value. 41. Yeah. Let us say substitute negative 2. Okay, it's a value that is outside the interval. So therefore, here are my solutions for 6.3. Now, going to part two. You are given a vertical netball pole. Netball. Two players are positioned on either side of the net. So if this is a pole, right, you need to know something. A builds a pole, A and builds a pole. But something you need to know. It means that here, I'm going to have a 90 degrees. Here also, there's a 90 degrees. And then you have another 90 degrees here. So it's forming 3 triangles. Right? So you have this triangle, this right angle triangle. Then you have also this right angle triangle. And then we have this right angle triangle, which has this 90 degrees. Good. So the same DE, a third player is positioned at C. We have a player here at C. Point C, B, C, D, E are on the same horizontal plane. B, C, D, E, same horizontal plane. And then the angles of elevation C to A and then A to E are X and Y respectively. There's the X and there's the Y. There's the X and Y. Then distance from B to E is Q. We have a distance in case you don't see it. This is the big case. The distance from here going here. Okay, they're saying write down the value of ABC. You already know ABC. A, B, C. This angle here. Let's get to A, B, C. this angle. So angle ABC equals 90 degrees. Let's get to the question. Show that AC, it's listed here. Okay. What do you know? AC. We know that there's AC involved, there's K, there's Y, there's X. So I need to join all these things here. So I'm going to start with AC. So I'll focus on this triangle. Then that has X and it has AC. So every time you have a right angled triangle, every time you have a right angled triangle, every time you see this thing here, you must think of this. The trig, ratios, and the theorem of Pythagoras. That's what you must think of every time you see a right angled triangle. So I'll apply the trig ratios. I know that AC sine of x, which is this, is the opposite side over the hypotenuse. The opposite side is AB. The hypotenuse side is AC. So this makes AC equal to AB sine x. This will be my first equation. Now, I'm going to look at another thing. They spoke about K and then Y. The triangle that has K and Y is this one here. This. Also, there's a 90 degrees. So remember, from here, we had the 90 degrees. So, tan, we're saying tan Y is equal to the opposite side, which is AB over K. So AB all over K. So this makes AB to be equal to K tan Y. This will be my second equation. So if you look at something here, AB is common, there's AB here. So I can substitute for AB into the first equation. So it's going to give me AC, right, is going to be equal to substituting AB. AB, it's K times Y all over sine X. That is my answer. I've proven that AC is equal to whatever I was given. Then going to the last question. It is further given that DAC is equal to 2x. DAC 2x. So this angle here, it is 2x. Okay. AD is the same as AC. So AD is the same as AC. Okay. Show that the distance DC between players D and C is. So they want us to show this distance DC. Now, we have a triangle. We have two known sides, right? Because we know AC already. AC is equal to K tan Y all over sine X. Then we know an angle again. These are conditions. So if you see a triangle, right? If you see a triangle with two sides, two known sides, and an angle, it has to be included. Included. The angle is included. Or if I have three known sides, there's something I can use here. Cosine rule. Cosine rule. They're actually saying that I should use the cosine rule, just that they want to glare you, you know how examiners are. So you're gonna say that BC, which is the side opposite the known angle, right? DC squared is equal to AC squared plus AD squared minus 2AD AC cos of DAC. Right, so when I do my substitutions, right, see what they said here. Very important for you to use. This is equal to AC whole squared plus. Now I'm doing my substitution. This is AC squared 2 now. Then minus 2AD. Then we have not AD, AC. Then AD. C again, because AD is the same as AC. So cos of 2x. Right, so if I simplify this, I'm gonna have 2AC squared minus 2AC squared. Just times that. Then I can change cosine. If I change the square identity, it is 1 minus 2 sine squared x. And then you're gonna have DC squared will equal to 2 AC. It's a common thing, AC squared. It's here and also here. So I'm taking out as a common factor. When I have 1 minus 1 sine 2 sine squared x. So if I do this one is going to multiply this. So it's gonna cancel out. So I have 2AC squared, then negative times negative, negative times this negative is going to be positive. So I have 2 sine squared x. So DC squared is equal to 2 times 2. Right, that's 4. AC squared sine squared x. AC, I know what is AC. Here is AC, so I'm gonna substitute AC, which gives me K sine y over sine x, all squared, then sine squared x. So if I look at this thing here, this square is going to be K squared sine squared y over sine squared x, then sine squared x. This cancels this. So it's 4 tan raised to 4 K squared tan squared y all over. Oh, that's it. That's DC squared. Then plus minus DC equals to 2K tan y. That's the final answer.